Hi, this is Nagesh Kumar Vinnakota, Software Engineering Manager at CapitalOne, and we have Gokul Prabagaren as a co-speaker of this session. First of all, hearty welcome to CDCon 2022, and thank you so much for having us today. We are going to discuss about how shifting left is helping CapitalOne in its CICD process. Before we go into the session, I would like to talk about CapitalOne. CapitalOne is the first U.S. bank to exit on-prem legacy data centers and go all in on the cloud. We are a tech company doing banking. CapitalOne is founder-led company on mission to change banking for good. And we are giving back to the community in the form of tech. And we have contributed to open source communities and projects like Critical Stack, Rubicon, and Data Profiler. We have also a couple of programs. One of them is Coders. So this is where our associates will work directly with the students. We envision a world where every student succeeds in the digital age and builds a better future with technology. And we have a CODA program where we look for the college students who are planning to pursue their career in tech or software engineering, but lacks computer science or degree. Our campus teams identify such top talent, give them training that will put them on the path to become software engineers. Agenda. We're going to give a quick recap of season 1, which is aired on CDCon 2021. We're going to talk about shifting left and advantages of using shifting left and how we have adopted shifting left at CapitalOne. Then we talk about security and the patterns that we have used as part of our pipeline, and automated functional testing and how we have started early stage of doing testing, and benefits of using shifting left. And with that, we will also do a curtain riser for season 3. And we will leave for question and answers. A quick recap of season 1. In season 1, which is aired in CDCon 2021, we mainly focused on how we evolved CICD process in CapitalOne. Over a decade ago, we have separate development team for developing software artifacts and DevOps team for deploying these artifacts into production. And each of these teams have their own responsibilities. Although it worked quite well, we have experienced coordination issues between these teams and knowledge gaps where teams and engineers lack complete control over the software artifact, and time delay in delivering quality software and operationally high cost maintaining these teams. During that time, we followed one of the leading linear SDLC methodology for building software artifacts. Though it is one of the best practices for building softwares, it has its own limitations due to the fact that testing can happen only after development. And it is hard to find the defects at the early stage of development. And once the software artifact is built and released by the development teams, it will be shipped over to DevOps teams, and these teams are responsible for deploying these solutions on the on-prem server. And maintaining these servers is an additional operational overhead. After a series of retros, we came up with 4 pillars that can address above concerns. And we strive to create software solutions faster with greater quality and lower operating costs that can meet the needs of customers. And we came up with you build, you own policy and adopting agile standards, migrating to cloud and DevOps tools. You build, you own, giving developers operational responsibilities has greatly enhanced the quality of the services, both from the customers and the technical point of view at CapitalOne. This enabled our developers to become more involved with the day-to-day operations of the software systems. And then we started adopting the agile, because when we are thinking about you build, you own, it is impossible without a platform or standards that is highly flexible. And we have adapted to the agile best practices by creating a self-organized teams and building iterative development and conducting a daily stand-ups and regular retros for the continuous improvement and software demos for the transparent transparency, and to keep track of the software artifacts. Then we have decided to focus on migrating to cloud. Our goal was to build cost-effective applications, so we wanted to move away maintaining on-prem servers or data centers. So we have vested time in migrating to cloud. I believe we are almost full in the cloud from the tech point of view. And we have conducted extensive research on the cutting edge technologies available in the software market, analyzing them with the proof of concepts to determine the best development tools available for our developers so that they can use and facilitate these tools in their DevOps journey and help them build and develop and build software. After a series of continuous improvements, we were able to build a pipeline that adapts to shifting left practices. So what is shifting left we are talking about here? It's a practice to find the defects, prevent defects early in the software delivery process, which allowed us to build and release cost-effective software much quicker with a greater deal of quality, security, and by following high standards. My friend Gokul will cover next set of slides. Over to you, Gokul.
Hey, thank you, Nagesh. I think with the context, whatever Nagesh said, with the whatever we discussed in previous CDCon and all those details and how we started our journey of DevOps, and the first place where we have gone is shifting left, right? Before we dive into the details of how we have adopted CapitalOne shifting left, let's quickly see what really shifting left is. My view, this picture depicts that clearly, right? In traditional SDLC way, most of the things like what we typically design, develop, and then we test it, and we do the analysis, which pretty much happens very much closer to the production phase, right? The turnaround time, in case even if we figure out something to fix those things, right? In traditional SDLC, takes a long time, and those are costly because of its vicinity towards the phase in which we are really delivering the value to the customer, right? So those kind of typical SDLC patterns, whatever we follow, we are adopting those things and doing them a bit more ahead in our lifecycle journey of software delivery. That's what on a very high level shifting left means. We still do those kind of things, whatever happens in SDLC, like testing, and we do analysis, monitoring, all those things, but pretty much those kind of things, particularly testing, happens the phase in which is closer to the development. So the turnaround time for those kind of fixes, when we figure out something is not going as per our expectation, when we are doing those things in development phase, it is pretty easy to immediately fix them, and then the cost of turning around is less. So that's what the shifting left pretty much means. So with that context, let's see how we have adopted in CapitalOne the shifting left. By now, you probably would have understood, like with the journey we have gone through, be the adopting the cloud, going all in cloud, or our DevOps journey through Agile or whatever, right? We have undergone a massive transformation in our organization, and we have now pioneered the DevOps culture across our enterprise. In fact, more than 85% of our deployments now happens in an automated fashion. Our goal is to go to 100%. We are strongly on our journey towards that. And out of those 85% of software delivery, 67% of our software delivery happens anywhere from 1 hour to few hours. That's a massive feat we have achieved from the days in which we were having different teams, not talking to each other, having a wall in between. From there, we have gone a long way, and then now most of our software delivery happens in an automated way. All this were possible mainly because of the investment we have made in our foundational pillars, like be it adopting the Agile, or going all in cloud, or standardizing our pipeline, or adopting you build it and you own it. Those are all the foundational pillars on which we are right now building our shifting left journey, right? So we have adopted shifting left in various places. To call a few things, on top of our foundational pillars, two areas where we are focusing today. One is in terms of security, another in terms of automated functional testing. Those are all the places where we see a major lift happening for us in adopting the shifting left. We will get into the details of those two areas in upcoming slides. First, let's focus on security. So this is probably a very abstracted view of how developer lifecycle happens. So they typically have a main repo and then make a fork, be like any developer, like they fork the code and then they start working on their feature branch. So where shifting left really comes into picture is they make their change and then they really run their local security scan, be it a vulnerability scan or SAT. There are various things we do, but those things happens actually in their local machine. That is actually our first checkpoint or first milestone where we really seen the shifting left pays value. So most of the things, what they figure out, it actually happens in their local machine, in their first execution itself. And then they say they figure out some issue and then they see there are a lot of things they can fix. Before they really check in their code, they address most of those things and then check in their code. From the fork, before it really reaches out the main repo, the similar process happens actually in our cloud environment, not in the security scan at their local machine. So in the cloud, the same step follows, and then we take care of those issues before it really reaches the main repo, and that is what really makes it to the production. All these things happens in few hours. The main advantage we see is two areas, as I was previously alluding. The first checkpoint is where developer runs the scans using plugins, or there are various ways they can do it on their local machine. That's first checkpoint. And second one, we run this in our cloud as well. So these two areas, when it comes to the security, we have adopted shifting left. And we do see a major benefit out of the, because before it really reaches the production, the hardened code only goes, and there is no way we can really get any of the vulnerable code into the production. And that's the one when it comes to the security. On the similar lines, we have adopted the same shifting left in automated functional testing, or any forms we can call this. It's pretty much automated. All our testing happens through the automated way, right? So the same life cycle as I was putting previous slide. Developer starts their journey and then they get their fork out of the main repo and then they start working on the feature file. So there is already a functional test written for the feature, whatever they are developing, and that is also embedded into their main repo. But they run those functional testing in their local environment using the power of Docker. So all those things written in the feature for their new functionality, whatever they're bringing in, those things are executed in their local machine. And then in case if they figure out there is either the feature is not working as per the expectation or whatever written in the functional testing feature file, so then developer fixes them. Mainly it's in their local machine. And then they again go through this iteration to get this right. If you see, the turnaround time in this case is pretty much instantaneous. They found a problem, they address it immediately. In case if you just compare this again, something which has gone to the production, and if you have to turn around those kind of fixes, you have to go through the cycle again and again, right? That is the major power of shifting left. So as I was discussing, the first checkpoint when it comes to the automated functional testing, they execute those things in their local machine. And then they fix all those things and then they check in the code. It goes through the similar iteration, but in our cloud environment. And that is our second milestone or a checkpoint, where the same functional testing is executed to ensure all the functionality what we are delivering is intact and it meets the expectation. And then we take that PR into the main repo, and that hardened code is what actually makes it to the production. So if you have noticed, there are two areas as we were discussing this. Automated functional testing and security, these are the two main areas we have benefited by adopting shifting left. Let's see what are the main benefits. So I was previously discussing what are the main benefits of shifting left. Fail fast, fail early, fail often. If you have seen from my explanation of typical developer's journey in delivering any of the functionality or feature to a customer, the turnaround time, as we were discussing the previous cases, it is too high. And if we are figuring out any issue which is closer to production, which is not actually failing early, right? You probably found out that issue which is very closer to the customer touch point. But by adopting shifting left, we have an opportunity to fail early. And also, since it is very close to development, the turnaround time is less. You are not afraid to fail often. So this is actually a main cultural shift, how we deliver the software using this. So because of adopting shifting left, we are able to quickly make the fixes in development phase in various checkpoints as I was discussing. Then we are able to ship our code in faster pace. The second major benefit we see is security. So I was discussing in the security section, any code which goes through this iteration, if you are adopting shifting left, and if you are addressing those things in the development phase itself, we can be assured that majority of all the vulnerabilities, any of the library which brings in those could be addressed. And shifting left is actually the way to do that. And by adopting that, we have hardened the code, and whatever we deliver to the production is pretty much taken care, and the code which customer really uses, those are actually secure code. So shifting left majorly helps us in that journey. Ship code faster. If you have noticed from this whole last 2-3 slides, you probably would have come to this conclusion, right? Because now we don't really are not afraid to push your code, because we have established the pipeline, which now gives us the liberty to push your code chain, which was taking days or months for us to deliver. Now it's taking few hours because of all the investment and also the pipeline we have established, which also ensures us that we have a strong pipeline which gives us secure code. And also we are not now really afraid of pushing those changes very often. So that actually enables us to ship our code even faster. So this way, we are able to achieve a lot of benefits out of shifting left, which is actually contributing to our customers' experience. You see this, whatever we have delivered to customer with security and a functionality which is meeting the expectation, we can definitely raise our bars in terms of customer experience. So we see majorly shifting left is actually helping us to deliver this. Till now, we have seen what shifting left and how we have adopted, and maybe the areas in which where we have seen major lift for us in adopting shifting left, and we have gone through that in detail and what are the benefits. So we just want to give a sneak peek into what actually the future or the season 3 is going to hold for all of you. It's nothing, it's pretty much the standardization and abstraction. And that's what our goal is, and that's what we are actually aspiring to be. Those two terms are, in turn, were pretty much abstracted itself for a reason. So the standardization here, as Nagesh was alluding previously in his contextual slide, the standardization, we have actually started the journey years ago, and we are still on that journey because it's a North Star we are aiming for. But the standardization, the benefits it is going to provide, it's humongous. What is standardization? Instead of each and every team or group going through a lot of customization in their pipeline or in their adoption of any of our platforms, we want to establish a standard which abstracts them from all the intricacies of how things really operate underneath, because those things really consumes time, and developers' time is precious. So we don't want to really spend a lot of time in those kind of really customized things. Instead, we want to establish a standard which makes developers' life easy and deliver customer features and ship code faster, so that we can really deliver whatever things which customers are looking forward from us. So we think that standardization and abstraction is actually the way we want to go, and we hope industry will also follow. So see, I think if we have an opportunity in later stage, we probably will explore more on what are the things we have really gone through in our journey of standardization abstraction in probably upcoming sessions. Some details about me: I'm Gokul Prabagaren, engineering manager at CapitalOne, and I have been pretty much focusing on big data related things. I have written multiple blogs, and I have given a lot of tech talks around the same area. And I have provided my LinkedIn and Twitter handles. If you are interested, you can hit me up there. Over to you, Nagesh.
Hi, this is Nagesh Kumar Vinnakota, engineering manager at CapitalOne, and being leading teams that build full stack software applications. And you can also follow me on LinkedIn and as well as Twitter. Thanks for having us here.
What's in your wallet?
Yeah, what's in your wallet?
Thank you everyone for the opportunity.
Thank you all.
Hope you all have a good time.